About integration by parts. We did a lot of integration techniques, but you need to know, what do I do? Mostly it's just a notation issue. What do I do if I get an integration by parts question and it's a definite integral, not an indefinite? Well, really it's just use the fundamental theorem of calculus. Remember, when you do a definite integral, isn't it just find the antiderivative and then evaluate? Isn't that how you evaluate a definite integral? Yeah? Okay. Now that's really what we're going to do. You're going to just find the antiderivative. You're going to blow out the limits. You're going to do your integration by parts, and then once you know the antiderivative, then you write your definite integral. So it looks like this. If you first look at this and say, all right, I'm going integration by parts because it's a product where one is not the derivative of the other. So it's not u sub. So what do you let u equal here? X cubed or log of x? Yeah, the best possible is if u is natural log. dv then is always the rest. So if u is natural log, then dv is x cubed dx. Therefore, based on the u choice, du must be 1 over x dx, and v is 1/4 x to the 4th. Now, the formula is for integrating some crazy product. u dv is ultraviolet v. uv minus v du. I remind you, make your u's and v's look very different so you don't get confused. In this case, then, right below, I'm going to say x cubed log of x is, now notice I'm not writing the integral, I'm just doing the antiderivative. All right? So, what is uv? Natural log of x times 1/4 x to the 4th. What's voodoo? Oh, I should have brought her voodoo donuts for that. Cool. Yes. Don't they sell like a bucket of old donuts? Yeah. It really isn't that all you deserve, is some old donuts. Just kidding. So v du then is 1/4 x to the 4th times 1 over x dx, yeah? Simplifying that is 1/4 x cubed. So the final antiderivative, I'm going to write the 1/4 x to the 4th in front of the log so I don't get confused as to where the log argument stops and starts. What's the antiderivative of 1/4 x to the 3rd? 1/16 x to the 4th. Now we typically put a plus c there, and I guess you could put a plus c there, but don't sweat it. You with me so far? All right, now the definite integral part. Here's where you say, all right, person reading this, the answer to this by fundamental theorem is the antiderivative. Now we just found the antiderivative. It's 1/4 x to the 4th log of x minus 1/16 x to the 4th. That's the first part of the fundamental theorem, and then the second part says evaluate that from, in this case, 1 to 3. All right. And so that's at that point, once you found the antiderivative, then you bring the limits back and say, all right, here's the antiderivative at 3 and 1. At 3 is, what do we got there? 81/4 log 3 minus 81/16 when we put in 3. Do you agree with that? All right, and when we put in 1, we get 1/4 log 1 minus 1/16. Let's clean it up a little. What's 1/4 log 1? That zeroes out because the log 1 is 0. We can combine a little like term, so we get 81/4 log of 3 minus what? What's the total of the 16ths, my friends? 80/16, which if we wanted to reduce it, what does that reduce to? Does 16 go into 80 even? 16 goes into 80 evenly? I'm telling you it does. 5 times 3. Okay, good job. I like it. All right, are you with me? All right, now then the hardest integration by parts problems. Not because the process is hard to execute, These are hard because they don't scream integration by parts. This, for example, this is an integration by parts question, but it doesn't look like an integration by parts question because it doesn't look like a product, yeah? I guarantee you that when I put this on the exam the first time, and I put multiple choices down, what do you think of good multiple choices if you were a teacher? 1 over x, baby. And more than half the people are going to buy it. So, yep, that is it. And did they just find the antiderivative? Log of x. No, they just found the derivative. That is tempting, and that is not it. Okay? Now, then, this is integration by parts because although students don't tend to think of dx as a thing, they just, it's this extra crap you write. It doesn't mean as you go on and get to diffie-q, if you take diffie-q, dx is a thing. It's a big thing. It's really important. So this really is a product. It is a product of 2 things, where log of x is a thing and dx is a thing. It is a product. And therefore, integration by parts should be considered. So let's go with integration by parts. What should we let u equal? Natural log of x. And therefore, dv is everything else, which is just dx. Du then is 1 over x dx, and therefore v is x. So when I go to integrate u dv and say it's uv minus v du, natural log of x dx is equivalent to uv, which is, let's call it, I'm going to rearrange the order a bit and call it x natural log of x, so it doesn't look like log of x, that's weird. Minus v du. X times 1 over x, so dx, which basically amounts to dx. All right, so if we integrate, x natural log of x is cool, minus, what is the antiderivative of 1 dx? X. Let's see. Now again, I could check that, take the product rule derivative on that, and you'd see that after the product rule, the x's would gradually drop out, and you just have a natural log statement. With me? Try the next one on your own, or through your mathematics. Look up at the mnemonic for choosing u above. Remember that lie. Log is best choice. The next best choice is inverse trig for you. Arctangent, I agree. Okay, so Harrison said let u equal arctangent, and I 100% agree. So you should have x arctangent of x outside the integral. Your new integral then is x over 1 plus x squared dx. Not wonderful, but at least doable. Did you then W sub that or U sub that, or did you could, if you're really good, you could try a mental U sub. Yes, and check. W sub, what's your W? 1 plus x squared, therefore dW is 2x dx, but the 2 needs to be moved over, yeah? Are you with me? So it becomes something like 1 over W times dW over 2, yay? Natural log, or 1/2 natural log of W, absolute value, 1/2 natural log of 1 plus x squared, yay? So is your final answer x arctangent of x minus 1/2 log of, do you need the parentheses, or the absolute value? Why not? Yeah, because 1 plus x squared is positive anyway, the absolute value really could be left off. You wouldn't be wrong if you left it, but I think on multiple choice you probably would not see it. So there's your final answer. What else might they write that in terms of log rules? What else could they write that as? You might, in a multiple choice, not even see that. What else could it be written as? Log of root 1 plus x squared is a possibility also. All right. Are you with me? Yes?
Why can't you split up the second? Yeah.
This into x over 1 plus 1 x over x squared. Good question. Very common thing here. So let's go. Let me look at this. Let me answer your question numerically here. 1 plus 2 over 3. I think we all know it's 1, yeah? If you split up a sum in the numerator, is truth maintained? Is that true still? Okay. If you have a sum in the denominator, can you split it up? Is truth maintained? You cannot split up a sum in the denominator, only in the numerator. Okay? So that's why you can't do that. Although that would be a great, much easier than what I did. It just doesn't work. Okay? Okay. Would you get your homework from yesterday, please? And let's go over the back side and then the front side. I think we did about the first half, yeah? So jump to the objective 3 finding extrema part, okay? Do you agree that on this number, whatever this is for, that there are two critical numbers, 1 and 2? Yes? But when you sign test, they're not both actual extrema. There's only a sign change at 1. Now my confidence is totally destroyed, so I'm going to screw this up. There is a blank, a min or a max. A min, where? X equal 1, y? Changes from negative to positive. Okay? X equal 2 is not an extrema because there is no sign change there. The second derivative test, number 5, first of all, you have to do the first derivative and the second derivative. Here's my first derivative. It does pay off to clean it up a little if you then have to take the second derivative. So I did clean up the first derivative. The second derivative, I guess you could leave ugly, but I cleaned up the second derivative as well. That was my second derivative. And then last but not least, you need to use those. So you need to find where's the first derivative, 0, which was x equal 1. And what's the sign of the second derivative at that point, which is negative. And therefore conclude based on a little doodle of concavity with flat or horizontal tangent that f has a what? Mass. At x equal 1, because what are two pieces of evidence for the second derivative test? Because f prime is 0 and f double is negative. Okay? You agree with that? Anybody say yes, that's what I got? Like I said, I'm really shaking. Absolute extremely, you should start with the extreme value theorem, which is to say absolute minimum occurs at endpoints for critical numbers. Those are the candidates. It's not much of a sign test kind of case. It's different. So you need to find critical numbers. Did you get that the first derivative is 0 and to find it 2 and negative 2? Yes? All right, then you have three candidates then. The endpoints are negative 3 and 2. The critical numbers are 2 and negative 2. So if you find f at negative 3, f at negative 2, and f at 2, and then compare the y values, the absolute min value of f is negative 15. And you know that the whole work is really justification, but if you want to, you could say because negative 15 is the least of the candidates in numbers or English. Okay? All right. Good enough. And then it occurred to me that you might not be familiar with that vocabulary in the next one. Do you know what local linearization means? Okay, that's a comment in some textbooks. For those of you going to mines, the Rogowski textbook is what they use there, and that textbook is a really good textbook. It uses this vocabulary a lot. Other textbooks do as well. Local linearization means tangent. That's all it means. So if you then need to find a tangent line, that might have been what you needed to get started, so you might not have been able to do this. But now that you know it means use a tangent line, then it's really a two-step process. Find the tangent line, which means find a point and a slope. My point was 3, 0. They gave it to you, and the slope was negative 9, 0, or negative 9, which you obviously had to use implicit differentiation on. Then you write the tangent line, and then the last part is when you use your tangent line to estimate, you plug in some nearby point into your tangent line and estimate. I got that it was negative 0.9 and that's supposed to be. Okay? So the work I would expect to see for credit is the work to get the derivative especially, but also the tangent line. You follow? All right. Any other questions on the back or the front? On 8 and 9, make sure you proved or justified your work by showing even or odd work. That was at the end of last semester, so I don't know how solid we are there. Questions? Yes? Fun. All right. One is the area remains constant at 1,000. And it's a rectangle, so it's a length into width. Find an equation that relates L, dL, dt, and df. L, dL, dt, dw, dt, no w. Okay. So, if I say that the area is length times width, then I guess this asks me to differentiate, yeah? Did you take a derivative? All right, so if you differentiate with respect to time, what about the left side? What is dA dt?
0.
Why is it 0?
But areas changing.
Yeah, it says the area is not changing, it remains constant. So it doesn't have, if it's not changing, it has no rate of change. So it's 0. The right side, that's a product rule. So L dw dt plus w dl dt. So I feel like I'm getting there. The only thing I haven't satisfied is the no w part. So what can I put in for w? Go back here.
1,000 over L.
Yeah. L must be, or w must be 1,000 over L. So if you put that in, then you get your 0 is L dw dt plus 1,000 over L dl dt. I believe that satisfies what they wanted. Very cool. And then B, my Find the length of the rectangle when its width is decreasing at 1 meter per second and its length is increasing at 10 meters per second. Now that you have part A, that'll be a little easier. For part B, if the length the width is decreasing at 1 meter per second, then that's dw dt and it's negative. The length is increasing at a rate of 10 meters per second. It's increasing, so it's positive. And when I put those in, that leaves me with just L as an unknown. And now it's just algebra to solve for L. I would maybe clear the fractions by multiplying by L first. You follow? Any other questions on last night's homework? Okay. Well, that's it. Hopefully that homework is not too much tonight. I know it's 3 pages, but we did some of it, and most of it's just AP practice on recent stuff and review. All right.
Yesterday I opened my stomach and I just like 60 million, just like 60 dollars. I had to erase it.
All right, people, have a great day.